Okay, so here we're going to be looking at the welfare effects of a unit tax, and this is from my book in microeconomics, and I'm Richard Friberg. So we're picking up from the same example that we used before, where we had specific functional forms for demand and supply, competitive demand and supply. Before we expressed them as the inverse supply and demand curves, so price as a function of quantity. Here it's more quicker to move directly to the demand and supply curves. So, but it's just equivalent, just shifting around. So demand, quantity demanded, 23 minus P, quantity supplied, equal to -1 plus P over 2. Okay, so we're going to be looking at this market. We could say first look at it if it's no tax, no distortions, just the equilibrium price and quantity that we calculated before. But what we're interested in now is to see if we're imposing a unit tax, a tax per unit. So it could be a tax per liter of alcohol, a tax per cigarette, a tax per liter of gasoline, etc. Some of the examples of unit taxes. How does that affect the market? Okay, so the key feature of such a unit tax, one can think that if it's imposed on one side, you can think it's shifting the supply, you can think it's shifting the demand, and that's often done in textbooks. I think it's clearer to just note that the third way of examining this, what we'll do here, is just noting that the tax creates a wedge between the price that consumers are paying and the price that producers are getting. Okay, so let's keep track of those two different. So quantity demanded will be dependent on the price that consumers or buyers are paying. Okay, so PB, that's the price inclusive of the tax. Whereas the supplier price will be net of the tax, so PS. So very simple. If price that producers get is I don't know, €2, the tax is €1, then the price that the consumers are paying is 2 plus 1, €3. So the tax is a difference between the price that the buyers pay and what the sellers get. Okay, so we have those two equations for supply and demand, and then we have a third equation that relates the price that buyers are paying to the price that sellers are getting. So they're equal plus the tax, which we can assume, for instance, is 3. So we also use letter T. That's an ugly T. We can use a letter T to denote the tax if we do so. So 3 in this particular example, numerical example that we're looking at, assume that the tax is equal to €3 per liter or ton or whatever we're looking at. Okay, so let's illustrate that in a figure. So we have, let's do all the curves here at one time. Okay, so this is as before. We have quantity on the vertical or horizontal, price on the vertical. We have supply, we have demand. We said that if this is a competitive equilibrium, we have a quantity of 7 and a price of 16. Okay, but now there's a tax. So that tax is going to be affecting the prices and quantities. So let's see how. Let's solve for the new equilibrium. So we have 3 equations and 3 unknowns. Okay. So let's plug this, the price. We know that the relation between the price that buyers get and the price that or price that buyers pay and the price that sellers get is equal to this. So we can use that in the demand equation, for instance, and know that also in this case, after the tax has been paid, supply has to equal demand. So we plug that in. So we say 23 minus PB, but then instead of writing PB, we're inserting PS plus 3. So we can say this is the same as PB like that. And that has to equal -1 plus PS over 2. Okay, so now we have PS as the only unknown in this expression. Okay, so we can multiply up the 2 here. So this gives us 46 minus 2 PS minus 6, take away the parentheses, equals -2 plus PS. Okay, so collecting terms here, 3 PS equals 42, or PS equals then 42 over 3, which equals 14. Okay, so we have one point here. We know that the price that sellers are getting is 14. So this is PS. Price that buyers are paying is equal to PS, which is in this case is 14, plus the tax, which in this case is 3. So that makes 17. Okay, so we have 17 here. We also know that what's the quantity here? So the quantity, we could use it either in the supply or the demand function. Let's use demand and quantity. So 23 minus the price that buyers are paying, of course. So 17, and that's equal to 6. Okay. So like that. So there's a new equilibrium here. Buyers are paying more, 17 instead of 16. Sellers are getting less, 14 instead of 16, and less is consumed on the market. Okay. Or yeah, both consumed and produced. So we can also look at the welfare effects of this, sign different areas. We can do calculations. So let's do that. Maybe switch colors here. Let's do that in blue. So we can first say what's a change. And as before in this chapter, we're using, as a welfare measure, we're using the sum of consumer surplus, producer surplus, and taxes here. So here we're just taking taxes as by their value. The value of one euro in taxes is one euro. So the change in consumer surplus. So as before, area between the demand curve and the price that consumers are paying is the change in the consumer surplus. So here, if we're thinking we're moving from a no tax equilibrium to an equilibrium with tax, price goes up from 16 to 17, quantity decreases, so the change in consumer surplus is minus area A minus area B, okay? Quantities decrease, price increases. What's the change in producer surplus? So here, producer surplus, area between the price and the quantity. This is a full area under perfect competition, no tax. Quantity decreases, the price that firms get decreases as well. So the consumer or producer surplus with the tax is a smaller triangle, meaning that the producer surpluses decreases with area C and D in the case of a tax. There's also a change in the tax indeed. This is sort of the point of the tax, is to raise tax revenue. There could also be other motivations, as we'll look at in later chapters, where there are, for instance, environmental issues. But for important feature of taxes is indeed that they raise revenue that we can use to finance whatever we want government to finance. So education or defense or social security spending. So what's the tax revenue here? Well, it's the tax. So we can say what's the difference between PB and PS, well, that's a tax. So that is a tax per unit times the number of units. So 3, tax of 3, 6 units. So tax revenue will be equal to 18. Or if we're thinking in terms of these areas, A plus C. And then if we're looking at the overall effect of welfare, we're just summing these different areas. So here, as before, consumer surplus decreases by A, producer surplus decreases by C, but those are just reshuffling to tax revenue. There's no distortions per se being introduced by that, whereas the area B and C are, as in the other cases, a deadweight loss. Okay, so this is again cases where buyers are willing to pay more than what sellers are willing to supply for. There are potential gains from trade here that are not realized. Why? Well, in this case, because the tax creates a wedge between the two. Okay. We can also calculate the welfare, the deadweight loss. So that's an important point of deadweight losses, is that it's not only a conceptual tool, it's also something that we can measure in euros. So in this case, we can think of that as a, as an area with a base of a triangle. So with linear demand and supply curves, the area is a triangle. We can think of the base of that triangle as 3, the tax, times the height of the triangle, 6 minus 7, 1, and divided by 2, since that's the area for the formula for area of a triangle, base times height divided by 2, or 1.5 euros or million euros, or whatever the units that we're working in. Okay, so that's very briefly on how we examine the welfare effects of a tax, or of a unit tax in particular.